Hi, I am Abhishek and this is Trello. What you're about to see is how the project fits together, its layout, choices under the hood, where AI plays a role, what could go wrong, and the ways it can grow. This is a collaborative task management application inspired by tools like Trello and Asana. The front end is built on React.js and the backend is built on Node.js with Express, and PostgreSQL is used as the relational database, while Prisma is used for the ORM. I already have strong familiarity with React and Node from previous projects. So instead of spending time learning and debugging a completely new backend ecosystem, I focused on building a system that was maintainable, structurally clean, and easier to verify properly. The key factors required in a software engineer. The reason was mainly execution reliability within 48-hour timeline. Now, coming to the AI usage, AI was heavily used as a development accelerator but not as on autopilot. Most of the AI assisted development workflow was done using Claude inside Antigravity. I mainly chose Claude Opus because, in my experience, it performs extremely well for architecture planning, large context reasoning, refactoring, and maintaining consistency across bigger code bases. Another thing I found useful was its ability to reason through structure and trade offs instead of only generating isolated snippets. For example, I used it for repetitive CRUD generation, architecture discussions, refactoring suggestions, debugging assistance, and documentation refinement. But then, generated code was never accepted blindly. Every major output was manually reviewed, every file it generated was manually gone through, simplified where necessary, asked for the agent to regenerate and refactor the code, and then only the accept button is clicked. Another issue with AI generated code is that models tend to over engineer and overcomplicate stuff. To avoid that, I maintained prompting constraints that define the project structure in complete definition. I defined the boundaries, I validated expectations and the coding standards, and I also restricted against unnecessary complexity specifically. So, the AI workflow was less about automatic code generation and more about accelerating implementation decisions controlled manually. So, now getting into the actual app, this is the login page, and clicking on this button will take us into the sign up page. Let me sign into an existing account. This is a test account by the name RF. I have entered the password and the username with the autofill. Let me sign in. The login and the sign up flow is completely JWT based, and the protected routes are enforced server side, not just on the front end. After logging in, users can first look at the dashboard. They can view their total tasks, and a specific overdue section is displayed where tasks overdue than the submission date will be shown to be acted upon immediately. Now, going into the project section, users can create projects, invite members. Let me create a quick project, and I can quickly add a member. Let me go to the existing database of the users. Let me add no Rohan. This is his email. Let me add him as a member. So he's a member, and I can also create tasks. Let's say this is the description. Priority is high. Let's say the due date is on 10th. Let me assign it to Rohan Gupta and create a task. So since I am the admin of this project, I can also change and edit later on, and I can delete the task. But if we look at from Rohan's account, he can only change the progress of the specific task. For example, for this task, he can only select to do, in progress, or done. And the edit button or the delete button will not be displayed as he's just a member, not the admin of this current project. So this project is a monorepo with two packages, client and server. In production, the React is compiled into static files and served directly by the same Express server that handles the API. So there is a single deployed service on Railway, no separate front-end and back-end hosting. No coarse configuration required. API calls go to API star routes, and everything else falls into the index.html, letting React router handle client side navigation. The database is PostgreSQL running as a Railway add on, accessed through the Prisma ORM. On the front end, I am using React 18 with Vite.js. Routing is handled by the React router across 6 pages. For example, under the SRC folder, we have under the pages, we have login, we have project details, and a 404 page. Basically, auth pages redirect you away if you are already logged in, and protected pages are wrapped up in a protected route component that checks authorization state before rendering anything. For state, I went with React context and use state. A basic, let me show you the projects dot, yeah. And then there is a single auth context that holds the login user and exposes login and logout functions. The JWT token lives in local storage, and on app load we call API slash auth slash me to rehydrate the session. The API layer lives in client slash src slash API. Each resource has its own service file for auth, projects, and tasks. There's a shared Axios instance that automatically attaches the bearer token to every outgoing request. Styling is all a simple vanilla CSS with a custom design token system defined in index.css. No tailwind, no component library. Every style decision is simply explicit. The design direction is dark mode or light mode with navy charcoal palette, glass morphism cards, and an indigo purple gradient for primary actions. The backend is Express.js organized into feature modules. Let me show you the folder structure. Under server, under SRC, we have 4 modules: authorization, projects, tasks, and dashboard. Authorization, projects, tasks, and dashboard. Each module has its own routes file, controller, service, and Zod validation schema. Under, let's take the example of maybe dashboard.js, where we can see everything is mentioned, and the controller handles HTTP concerns, parsing the request, sending the response, and service layer is where all the business logic and Prisma queries actually live. Let me show you the schema of the Prisma I have made. The two most important pieces of middleware are authorization and RBAC. The auth middleware grabs the authorization header, verifies the JWT, and attaches the decoded user ID to request.user. If the token is missing, or invalid, it returns a 401 immediately. Under RBAC middleware, it is a higher order function where require role takes the allowed roles as arguments and returns the actual middleware function. It requires the project member table to check if the requesting user is a member of that project. If they are not a member at all, it returns a 403. The membership record, as you can see, it generates a 403. The membership record gets attached to rec.membership and the request moves on. Access control is enforced once at the middleware layer, not scattered across controller logic. The database has four models. User stores credentials. Passwords are hashed with bcrypt. The database has four models. User stores the credentials. Passwords are hashed, and project is a workspace with name and description. A name, a description created at and updated at automatically is generated, and then project member is a junction table that links users to projects and stores their role, either admin or member. As we can see, member or admin. There's a unique constraint on the user ID and project ID combination, so a user can't be added to the same project twice. Task belongs to a project. Task belongs to a project and has two separate user relations: creator ID and the assignee ID. The creator is the person who made the task, and the assignee is the person who is responsible for the task. Status and priority are both database level enums. Basically, to do, in progress, and done is an enum under status, and priority is an enum of high, medium, low, and urgent. On the permission side, only admins can create and edit or delete tasks, but the status patch endpoint is also open to the assignee of task. So members can move their own work forward without needing the admin to involve. All primary keys are UUIDs, which avoids ID enumeration attacks. Finally, for extensibility, the system was intentionally designed in a modular way. So future additions like notifications, drag and drop Kanban, audit logs, file uploads, activity tracking, and real time collaboration can be added without rewriting the core architecture. And lastly, the app is deployed in a specific URL, which will be attached in the GitHub link I will be mentioning. And this is the overall architecture. This is the tech stack, as we already discussed. This is the database schema, specifically where the user table is tied up to the task and project table, and the project table and the project member table accordingly. This is the project structure. These are the API endpoints, and this is the authentication flow, and this is the specific flow chart which includes all the role based access controlled workflow, and the front end pages and the componentry for the front end pages. Yeah, so that's been it. That's been the whole explanation. That is Trello. I am Abhishek signing off. Thank you.